Hello boys and girls. Today we're going to talk about lesson 10.4, which happens to be about line symmetry. And I want you to be thinking as we go through the lesson today, is there a connection between reflections and line symmetry? So if you remember reflections, let's say that I have this face here on the left side. This is my pre-image, and it is facing the right. When I put my mirror on here and go ahead and reflect that image on the other side, my face is facing the left. So when we have a reflection, they usually face in opposite directions, okay? So let's take a look at our vocabulary today. We have the word line symmetry. And line symmetry is when a line of reflection is in the middle of a picture or object. And so down here at the bottom of my paper, I tried to show you a line symmetry line here in the middle of a star, but since I didn't have a mirror, it didn't turn out exactly the way I had planned, and stars are kind of difficult to make anyway. But I want you to understand that when we have a line of symmetry, the left side of my picture should look the same except in the middle of the picture on the right side. So I've got two pictures here on the other two sides of the star. This would show you what that would look like before I use the mirror. And then when I place the mirror on that line, I should be able to create the other half of that drawing. So this would be my line symmetry. And same thing over here. This would be my line symmetry, and I would have the other half of that drawing on the right side of that line. So let's take a look at some shapes. I have a triangle here. And when we are looking for lines of symmetry, we want to cut out the shape if we're able to and fold it. So if I fold this on this side, you can see that none of my edges overlap. So this would be a line of symmetry here in the middle. And I like to go ahead and draw that line because if I'm counting those, it helps me keep track. So that would be one line of symmetry. I can also take this triangle and I can fold it this direction, and again, it doesn't overlap, so this would also be a line of symmetry. And if I fold it this direction, again, I'm not overlapping, so this particular triangle has three lines of symmetry, okay? Now, I have another triangle that does not have three lines of symmetry. You'll notice that when I take this triangle and fold it, I have a line of symmetry down the middle. But if I try to take this corner up here, you can see that that's not going to form a line of symmetry because my edges do not line up. And if I try to take this corner and fold over here, same thing. So this triangle only has one line of symmetry. Let's take a look at this shape that kind of looks like a kite. This one, if I fold this direction, here is one line of symmetry. But if I try to take this corner over here, it doesn't line up. If I try to take this corner over here, it doesn't line up. So this particular shape has one line of symmetry. Then the almighty square, I already did that one, but I actually measured this to make sure it was a square, made sure I had all my sides the same length. But as you can see, I'm able to fold it this direction, and I can fold the diagonals. So I end up with 1, 2, 3, 4 lines of symmetry for a square. A rectangle, on the other hand, I've got a whole sheet of paper here. I can only fold it this direction, which would be 1, and this direction, which would be 2. But if I try to take this corner and fold it over here, as you can see, that is not going to form a line of symmetry. Same thing if I try to go that direction, it won't work. Okay? So that's one way we can find lines of symmetry. The next thing I want to talk about today is I would like to review multiplying whole numbers by a fraction. And I've got some number lines set up here to help you. And I've got some reminders. The first thing, when we have a number line and we don't have any numbers or fractions or decimals under our graduation points, and for this one we're doing fractions, we want to count the graduation marks after 0 so I know what my denominator is going to be. So this would be 1, 2, 3, 4, 5, 6, 7, 8. So that means my denominator is going to be 8. So this would be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and of course 1 is also equal to 8/8. Okay, so that's what we would do first, count the graduation marks after 0 so we can figure out what our fraction and our denominators are going to be. Then we're going to count the jumps to determine our whole number. So you'll notice I have 1, 2, 3, 4 jumps. So if I were going to write a problem for this, and I kind of didn't leave enough space here, but I'm going to put the whole number 4 times, and then our fraction is 1/8. Okay, so we're going to multiply the whole number times the numerator and place over the denominator. So when we multiply 4 times 1/8, we're only going to multiply the 4 and the 1. So my answer is going to be 4/8. Okay, or 1/2. Now let's do another one. We have this number line here, and notice that I have 12 over 12 equals 1 down here at the bottom. That kind of gives me a clue what my denominator is going to be, but I'm going to go ahead and count just to double check. So remember, I'm going to start after the 0, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that is 12 over 12, so that means each fraction is going to be a 12th. So 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, and of course 12/12. Now I have 1, 2, 3 jumps, which means my whole number is going to be 3 times 1/12. Remember, we're going to multiply the whole number times the numerator only. So this becomes 3/12. Can I reduce that? Yes. I could divide both of those by 3. And that's going to equal 3 divided by 3 is 1, and 12 divided by 3 is 4. So that reduces to 1/4 if you want to do that. Okay, let's take a look at the last one down here at the bottom. Count my graduation marks. 1, 2, 3, 4. So my denominator is 4, so this will be 1/4, 2/4, 3/4. Now notice that this one I have jumped 2 places. Okay? Because I skipped this one. So this is going to be 2 times 1/4 equals 2/4. This actually reduces to 2 divided by 2 is 1, and 4 divided by 2 is 2. So that actually reduces to 1/2. And we know that 2/4 is equivalent to 1/2. Okay, so that's our review on how to multiply whole numbers by a fraction. Remember to count your graduation marks after the 0. You're going to count your jumps to get your whole number, and then you're going to multiply that whole number times the numerator only and place that over your denominator. All right, so we've covered how to find lines of symmetry and shapes by folding and counting those or drawing the lines. And we've also talked about line symmetry. So, is there a connection between reflections and line symmetry? I want you to write your answer and bring it to class. Thanks for tuning in, guys. See you next time.